Hello, this is Tim Alec, and this is my demo for fluid simulation. I work with Phineas and Dario Rueda, and I'm going to go ahead and run our fluid.simulation code. And here you can see we have all the particles which have been dispersed within our pan, and I'm going to demonstrate the splash simulation that we created. So if I tilt it, see they tilt and then it creates like a splash with different higher velocity going up, and then it splashes back into the other ones, and then on the right side it does the same thing. So you can kind of do like a back and forth type of movement, just like that. And if I go ahead and go into my doc, I will discuss the exact code that I worked on for here. So I established gravity, which is down here. Gravity multiplied by the delta time. So the delta time basically represents the time elapsed since the last frame. So this ensures that there's a smooth motion with the gravity. Um, and then also down here, we have this function we want to make sure that the particles stay on the floor of the pan if they're within bounds. So we don't want like them to be on top of the pan. We want them to be staying on the floor. So we have the horizontal bounds, the x, and then and z, and then within the pan boundary, and no splash is occurring when splash time is less than or equal to 0. And then we have a tilt threshold right here. So this is threshold to we don't want the splash to be happening unless a tilt occurs, because there is a time when I did not apply the threshold and splashes were occurring even when the pan was staying still. There would have been particles going up and down, so I had to create a threshold, and then we determine if with a boolean if the tilt has that of the x has is greater than the tilt threshold and z is greater than the threshold, so it'll be true if that is the case. And then these are also other booleans to see if it's going to splash from the top, the bottom, the left, or the right, depending on the z and x values in comparison to the boundaries. And I set 0.95 times the boundary so that the dots will create a splash when they're at the 90 like 0.95% of the boundary, so that they don't when they splash you could kind of see the splash better because they're inside of the boundary, not on the boundary or outside the boundary. They're barely just inside the boundary, so when it splashes you could see the effect. And then we also have a if is tilted and splash top, and splash bottom and splash left and splash right. Then we'll go into the code that my other teammates did to create the actual splash. And yeah, thank you.